Last week, what we were doing was trying to give you idea how many kinds of figures you can make. So single axis, double axis, and how to make the figure much better. We will continue with that, but as we are fresh right now, let's do the important things first. So we know how to write figure caption. Yes? We know? Aaron? Yes. The yes should be very loud and confident. Yes, we can. We know how to write the figure caption, and I have shown you a little bit how to write the result. So today what I will do is I will try to show you the difference between caption, result, and discussion. Because you know, when you write a paper, there is a result and discussion. So we need to write a caption, result, and discussion of the same figure. So what are the basic rules? I will take an example of a very simple figure and then write the caption. I will take help from you, write the result, and try to write the discussion. So this will give you an idea what is the difference between a caption, result, and discussion. So let's start with a very, very simple figure. So this is our y, that's x. And let's say our figure looks like this. Something like this, and then I join them by some kind of a line. So this is our data. So this is whatever x, and just think of anything. This is x, this is y, okay? I will put some numbers. I will need that later on. So let's say something like this, and also this will have some numbers. Although you should put the points inside, but just for the sake of it, I'm just writing here. Maybe this is something like this. So this is our data. So what is the caption? Let's say this is figure 1. What is the caption? Anybody? It's very simple.
Variation of y with x.
Exactly. This is as simple as this. Variation of y with x. Very simple. And you can replace the word with as a function of. So variation of x, y as a function of y. And anything else? You write what you see. There is a line, right? So what is that? Ken, how do I write the line?
The line showing line data point is a guide to the I only.
Right. The line joining the data points is a guide to the I only. Okay? So now the figure and the caption is done. So result. The easiest option is start with the first line of the figure caption, but use the word shows. In here you cannot use the word shows. Now in results I will use it. So I start writing the result for figure 1. Now see, I am not writing fig.1 because I am starting a sentence. In the middle I can write fig.1, but when you are starting the sentence you cannot write. So figure, full, F-I-G-U-R-E. Figure 1 shows the nature of variation of y with x. That's nearly the first line. This is a very simple rule. Follow it. Later on, when you develop, you will make it better. For now, we just use the first line, but I use the word shows. But this is not complete result. This is just saying that is how it varies. Now we have to write how. We need to put in numbers. We need to describe this figure. So see how I do it. Let's say this you need to do in your PowerPoint. These 2 lines that I draw, this is not your data. Your data is only this part. So now I am doing some enhancement just to help the readers understand the figure. So I draw these 2 lines. Now I write, as x varies from 30, as x varies from 0 to 30, y increases from 1 to 6. Simple. However, if you are sure that this increase obeys a certain equation or a certain nature, like increase linearly or increase exponentially or increase logarithmically, you can write it increases linearly if this is a line. If. Okay? So I describe that part. So this I am writing it like mathematics, but you can just write x between 30 and 60. So between 30 and 60, or in this range, y saturates at 6. So this is flat, right? So I say y saturate. This means saturate or does not change. Y does not change, okay? So this is saturate. Y saturates at this value, at that value, from sharply, linearly, exponentially, whatever, and it goes back to 1. From 6, it goes back to 1. This is result. I explain the nature of the variation with numbers. So this is basically what result is. Very simple. In your real case, it won't be that simple. And I will show you how to do that. If you have image, you can do the same thing. However, I start with the most easy one. It's scatter plot, I write result. You need to know how to use the correct word for something, for some variation. You need to know your data and how it looks like. For example, your data is like this. And then, so you know that this is called noise. You need to know this, okay? This is signal, okay? Sometimes your data might be like this. This part is called inflection. This kind of words you need to know a little bit, not much, just a little bit. So if you know that this part is saturate, we call saturate. This is a decrease, this is increase. Or we can also say this is decay and that is growth. So this part may be considered, if you are a biologist, then this is growth and that's decay. If you are a physicist or chemist, then this is increase, saturate, decrease. See the difference. I am using the word shows, that's one. And I am describing. This description was absent here. In the caption, don't describe it. You describe it in result. Don't describe your data in the caption. Then the caption will become very long. However, I should also tell you that there are many medical journals. In the medical journals, they describe their data in the caption. But I am just telling you the simple one first. Which one? Yes. Saturate. S-A-T-U-R-A-T-E. Saturate. Anything else? So that part can be called a growth and that part can be called a decay. Also, I am giving you alternative words. Yes, Gordon?
Should there be a comma after the 30 to 60? It has to go in the resource,
Yes.
At the sixth row
between 30. Oh, okay, here, right? Yeah, of course, you can. So this is a very simple result. Now let me go to discussion and see how the discussion is written. You remember this page, right? I need to go to the next page. Now I go to discussion. So we know caption, we know result. Now is discussion. Our data that we write y with x, let's keep it y with x. Or do I need to name it? For writing, if I have a name, it's easier, but never mind. First line. Now I am bringing in new things. The variation of y with x, which one? Figure 1. So I put that in bracket. Follows a well-known equation as described previously. Maybe I should have written previously here. That means this paper is already published. Previously by Ray et al. And I put the reference. So now immediately you can see what the difference is. Caption and result should not have references. Now I bring in references in discussion. So first I say that the data I got follows a previous report. Report by whom? Report by this guy, Ray et al. Now I have to tell you something about this et al. And this. So et al. Means when there are more authors in a paper. Several authors in a paper. 1, 2, 3, 4, 5. So the first author is, let's say, S. Ray. The second may be, third may be, and you have many authors. I cannot write so many authors. In that case, I just write the surname, the family name of the first author. This is the first author. I write the family name of the first author, and I write and others. In Latin is that word, et al. Okay? And others. However, you need to know how to write that et al. So the first author is Ray. I write Ray. Et al. Et. By mistake, many of you do like this. That's wrong. Et al. Is this. Okay? Not only that, it should be written in the italics. It should be italicized, okay? In words, you have that italics, right? Like the words which are like a little bit like this, okay? We call italics. Aaron, you understand? Bold, italics, and underline, right? So you have used this one. So it should look like this. That is et al. For example, if you have some experiments which are like in vitro, in vivo, in situ, they are all like this. So in vitro, in vivo, or in situ, these words are all italics. So that is the meaning of et al. So that is the et al. Over there. The first thing you need to learn, references come in discussion. Not only reference, you have to explain your result. Remember the first page. Remember the first page. I did not explain anything. I just said, I just wrote what I saw over here. So y varies from here to here, then saturate, then come down. I did not explain. No science. I just write down. This is just simple what I see. So it increases, it saturates, and it decreases. That's it. I did not explain. In discussion, you do that. The increase in y at small values of x. The increase in y at small, the initial increase. Remember the figure? The figure was like this. So this increase from something to 30, this increase, okay? The increase in y at small values of x, but small is not technical. What do you mean by small? Small, big, they are all non-technical. So I explain. For x less than 30, that means in this range, matches the report previously published, and I give the references. Okay? Reference 3, 4, 5. Now, I intentionally made a mistake here. Now I want to show you that if you have two references, consecutive means next to each other, 1, 2. If you have two references, then you write with a comma. If you have a continuous set of references, more than 2, you write with a dash. So that means you write like this. Okay, you don't write 3, 4, 5. But remember, it should be continuous, 3, 4, 5. If it is not, then write like this. If it is not continuous, then 3, 5, 7 to 9. That means 3, 5, 7, 8, 9. It looks very simple. It is not simple. You have to write the references from small to big always. So if you have several references like 13, 25, 18, 27, 35, always write from small to big. 3, then 5, then 7, 8, 9. You cannot write like this. This is wrong. So if you write a reference that it is 3, 2, 14, 13, arbitrary, no, you cannot do it. It has to be from small to big, increasing values, should be like this. In this part, you see, what I'm trying to say that whatever data I have is matching something. Now, this is not always the case. Sometimes your data doesn't match. However, whenever I write the word however, there should be However, the results from somebody et al. Reported a continuous increase in Y with X without any saturation. This is the difference. I obtained this, but somebody else obtained like this. This is the difference. This part is okay. However, this part is different. I write that. So what I am doing, I am comparing somebody else's data with mine. And I say, okay, I obtained this, but that guy somewhere obtained this. You write down with a reference. And then you need to explain it. So you need to explain why I got this and he got that. This is probably due to the temperature dependence in Y. Some reason, I need to give some reason. And then you can put references. Like in this way, you explain your data. Why this is increasing, why it is saturating, why it is decreasing. You have to do entire thing. So I am only midway. I am up to here. Then I have to explain this one. Explain everything. Compare your data. Not only with those that support your result, even those that do not support your result. So compare. Compare means you may be good compared to others, you may be worse compared to others. Cite both of them. With respect to that paper, I am better. With respect to that paper, I am not as good. And this discussion should contain references. And compare your results with other people in the world. And do it fully. Now, if you look at the structure of the writing, you can immediately see that generally, it is not always true. Generally, a caption is like 3 or 4 lines. A result is like 5 or 6 lines. Discussion is more, you can see. So this is general, that a caption will be like this much, result will be like that much, and discussion will be like that much. Have this idea in mind. If you see your caption is that big and you cannot think of any discussion and your discussion is 1 line, you are wrong. It cannot be. You need to compare your work with others and explain the data in discussion. So this is your science. Explain in discussion. However, this part is not explanation. This is description. Okay? Describe in result. This is describe. I am just describing that it is increasing, then saturating, then decreasing. That's it. What are other differences? No reference here in the results. I have numbers, but no reference. And what is the caption? In the caption, I just say, what is this? I don't describe. I don't say that it is increasing, then saturating, then decreasing. I don't describe, I don't explain. So this is very basic. This includes description, and this is explanation. You explain the science. Why it is increasing, why it is saturating, why it is coming down. And this contains reference. And as a rule, explanation is the minimum writing. Let's say 3 lines, 2 lines. Result is like 5 or 6 lines. And discussion is like 10 lines, normally. And should also contain references, roughly. If you have questions, now ask me.
Professor,
Yeah.
I have one question. In the course, we use brackets for reference, right?
No.
But sometimes the paper they will use a small word on the right top.
Yeah.
Is that okay?
Oh, no. It depends on journal. So that's journal formatting. So what Aaron is asking is, when we write reference, there are many types. Some journals will write the reference like as a superscript. Some journals will just write a number without the bracket. Some journals will write with a square bracket. There are many types. Not only this, you see, journal formatting is a very, very tough job. So for example, you write the references before the punctuation. You see, there is a full stop here. You write it before. Normally, this is convention. There are many journals, they use it afterwards. So for example, so you stop and then you put like this. So these are journal formatting. What I'm doing right now is just writing. Now, depending on the journal that you want to send your manuscript to, those will change. And each time you get a rejection, you send and they say, oh, your paper is not good. Then you need to do this work. Because from this journal to that journal, these styles will change. So you need to do that. But now most of us are using EndNote. So EndNote can take care of it. EndNote can format it. Remember the rules. There should be no reference in result. There should be reference in discussion. In result, you are not explaining the science. You are explaining the science in discussion. Result is description, not explanation. This one is explanation. Result is describe. And try to describe as clearly as possible. If you read this, if you close your eyes, you will basically see such kind of a graph in your eyes. So you need to write it like that. What you see, description. And if something is not very important, you don't need to write. Sometimes you will get so many different kinds of data, like you clearly know those are not signals, so don't write about them. Just see, okay, I see a signal here, here, and here. That's it. But if that is really important, you have to write. So here you say, this is signal, and this is some variable. So you say, okay, I see a signal at 20 and at 40 and 50. Just write that. You don't have to worry about those small noise or something which is non-scientific. Just maybe an error in the measurement. Any question? No question, right? So let us do one exercise. Yeah.
Sometimes discussion in some papers, there will be only very small section will be there. Say for example nature communication paper. So discussion part is very small. Most of the time the result part is very much described. So at that time, why the description is so small?
No, description is not small. So what I say is generally this is the length. Generally, caption is the smallest, result is a little big, discussion is longest. This is the general thing. Now you might say that what happens to a letter kind of journal where there is only 3 pages? You cannot write more than 3 pages. Then you have to write small. So you need to know how to write small. Writing small, that means few lines, and skipping the explanation is not the same. You can still explain in small words. Okay? You can still explain.
Concise.
Yeah, concise, in a concise way. That means you don't have too many words to use. They don't allow you. You have to write small. But this is a general rule. Like I said, in medical journals, the captions are that big. In medical journals, in many medical journals, for example, if you go for blood, you look at the caption. Oh, the caption is like 1 page long. They describe, they put the result in the caption. But that's a classification, a special kind of writing. It's not general. What I am teaching is general. So now, when I look at the figure, I have to make up something, right? I make up, so this is height in centimeter, that's 6. Okay, so it cannot be a human height, maybe some plant or something. So what I write is this: variation of height of plants as a function of growth time for. Now here is the trouble because there was no ABC, only symbols, right? So I say, okay, this triangle, this is for this tree, then that one square is for the rhododendron and the diamond for marigold. I make it up. I don't know. I just make it up. You can say ABC. Okay, no problem. This is for the A tree and the B tree and the C tree. I just gave 3 names. And then the lines joining the data points are a guide to the eyes only. So this is the caption. Drew out the symbols, that triangle, that square, and that this. This is required. Otherwise, I don't know which one is for which one, because there was no ABC. So you need to do that. So if you haven't done that, put that. How to do that? Like this. Is for bracket like this, and you put the symbol. That's for this one. So I know that the triangle is for banyan, and the square is for rhododendron, and the diamond is for marigold. I know that. And then result. So variation of height of different kind of plants are shown in figure 1. Fine. The growth rate for banyan is the highest because it was the steepest. The growth rate. This is time and this is height. So that must be the rate. So that is the highest. and it continues to grow even after 10 days. So if you see, it continues to grow. I am trying to make the result interesting. How you do that? You bring out the contrast. Contrast means the difference. What is the difference? In contrast. If you look at this, any data, this is a particular, this is not my data. I took it from the internet. You see, this is growing. I want to make it interesting, and I see, oh, in comparison to this, these two are not growing, right? So I use this word, in contrast. The other two groups show some kind of saturation. That means it is not growing. The banyan is growing very fast, and it continues to grow. However, the other two sort of flattens out. It becomes interesting. When you show to the readers in contrast or similarly or something, it becomes more interesting. In contrast, the other two groups grow at a slower rate, and their growth tend to saturate after 10 days. Yes, it saturates, right? And now is a test of your eye. What you can see from the data. See, this data I did not read. I just pick up this data from somewhere. And then I think I need to make it interesting. How to do it interesting? Then when I was writing, I saw, if you look at the data, you will see another interesting thing. When they start at 0 day, the height of the diamond, that means the marigold, was actually the highest, but it ended up being the shortest. So I think that this is very interesting, that initially on day 0, it was tallest, but after 10 days, it is the shortest. So I bring in this contrast, and that banyan probably started the smallest, end up being the tallest. So this is how I make the data more interesting. You might say that, do I need to do this? If you find in your data that wherever you see some contrast, this cell is growing this way, the cancer cell is growing this way, the other cell is growing that way. Bring in the contrasting character. That makes your writing much, much interesting. And then I write a little bit. So if you look at my length of the discussion, so my discussion is like 1, 2, 3, 4, 7 or 8, 10 lines. So I bring in some factors. I bring in like, okay, it may be the growth may be gene dependent, environment and soil dependent. Okay, I give some reference, and what is new in this work, maybe this was not reported before. So I write that this was not observed before. Then only my paper can be accepted. Otherwise, if I report something which is already published and reported, then the journal will not take my paper. I have to show where I am new. So I say, okay, I am new here. And I bring in some concept of temperature, that the temperature may be affecting the growth. And I put a future. It may be interesting to study the growth at low temperatures. Maybe this is done in the tropical countries. That is discussion. You bring in all kinds of information from around the world. What is happening in your research? And you put them together with references. So when typing, you see, I just did it very quickly. So of course I made mistakes. I did not put a space here. I forgot to put the degree. I only put C because to degree I have to go to symbol and then bring this. That will take a lot of time. So remember that space is very much required. These spaces and how to write this 12, 13, 23 to 45. You see my dash over here. So when I write 7, 9, 11, so I do it from small to big. These are the rules. Normally we keep it. So try to make the writing very interesting. Now, this is a data, right? Try to look at the data and find out how to express the data. This is data. Clearly, in English, the girls enjoyed more. In other 3 subjects, the boys enjoyed more. Now, so that's fine. So how would you express that in number? So like Punctuation writes that in science, maths, and physics or whatever, boys had approximately 1.5 to 2 points, so that much. So that much is 1.5 to 2. 2 points higher enjoyment than girls. So she is trying to bring out a number. How high? The boys enjoyed more. How much more? So she says between 1.5 to 2. So maybe this is 2, maybe this is 1.5, this is 1.5. This was not in the data. Of course, in the presentation is there, but she is trying to find it out. How much? Can I represent this by a number? Can I represent this by a number? That is a training. You need to see how to represent that. For example, now, if you look at mine, I did not do it that way. How did I do it? I defined another number. I said the enjoyment score ratio, boys is to girl. The meaning is the same. I bring in this ratio, boys is to girl. That means boys is to girls. It's 2.4 divided by 3.5. So you can see this by this will be more than 1. More than 1, right? The ratio 4 divided by 2.5 is 1 point something. This is also 1 point something. This is 1 point something. But this one is less than 1. This divided by this is less than 1. Maybe 0.75. So I express that as a ratio. Huishuan expressed that as a number, just as a number. How much is the difference? So this is 1.5, 1.5, maybe 2. I express it as a ratio. Look at that. How to express these contrasting features with numbers, if possible. When you see some image, if you can express image with a number, it's even better. But in most cases, probably you won't. But if you can express image with a number, that's good. That's what I said here, you see. For any subject was the highest for category 4 at 1.5. The enjoyment score ratio for boys is to girl for English was less than 1. I'm trying to bring in the contrast. So for all the other 3 subjects, the boys enjoyed more. So boys is to girl will be more than 1. However, for English, it's less than 1. That clearly tells you that the girls enjoyed more. So it depends on you how you look at the data. So Huishuan expressed it just as a difference. So she expressed it as this number, 3.5 minus 2. So that's 1.5. And I do it as a ratio. You can do it as you like it, no problem. She has bring in a very, very nice thing. So she thinks, why is this, right? Why the girls like language and the boys like science. Now she brings in the concept of the left side of the brain and the right side. There is a contrast. How the boys think, how the girls think. That's a very good thing. That's exactly the way to do it. Now you bring in the science. Of course, there are breaking of rules. So for example, if you look at the big women in science, like Marie Curie, it's completely the opposite. So when you bring in the general trend, the general trend is, let's say, the boys work with the left side, the girls work with the right side. But there are some breaking of rules also. Some very big scientists, for example, my previous professor, Lin Li Cheong, okay, she just got the Academician Award of Sinica. And she is so good that probably her brain is like a boy. I mean, she also maybe thinks with the left side or something. Rules, and there are breaking of rules. Bring in the references, right? So you say, my data is okay with the published data, 20 references or 5 references. However, that data did not match with mine reference. Not only that, why it did not match? You did the same experiment. You did the same OCT in your lab, and somebody did OCT in somebody's lab, right? Some result matches with yours, you are happy. Some result doesn't match with you. Don't be sad. Just tell why it did not match. It can always happen that your data and somebody else's data did not match. Okay, Gordon is trying to make this something UCNP, and he's saying, okay, he puts in melanin or something like that, and then the published paper looks like that, and mine look like this. That's okay if you can explain it. If you cannot, then it's a problem. So science is about explaining. So you say, my image is higher resolution than that guy because of this. Because I use this software, because I use that one. Then you bring in another paper. Then you see their field of view or depth of view is better than yours. Then you explain why. If you can, and all of this comes in the discussion. If you can do that, then it's perfect. This is the key, okay? So what we are doing, we are making the figure. I did not show you figure designing, I will do it. So figure, write a caption. Once you do that, so let's say in your thesis you have 10 composite figures, A, B, C, D, and you write the caption. That PowerPoint file is the first file you make before you start with a Word file. Once you have that, then you open a Word file. It's a completely blank file. Then you start to think, oh my goodness, it's a blank file, what to do? The first thing, don't try to write the title or the introduction. start with the experimental first. That's the easiest thing. So just write experimental. So what are the experiments you did? Then you will say, oh, I did OCT on, so write OCT. Check how other people write it. See how the OCT is done and how you have done it. So what is your subject? Is it a pig, or is it a mouse, or is it something, okay, or is it an onion skin? Write about your subject. Now, what is the difference? The difference is a completely blank Word file and a Word file with few pages written makes a big difference in the confidence. A blank file, you know, you need few cups of coffee to start writing. But once you start writing and you see you have already written 2 pages, then your confidence goes up. And start with the easiest one. What is the easiest one? Experimental. That's the easiest. When you write your thesis, start with the experimental. Then you already have the figures, right, in the PPT. Then go to results. Figure 1 shows this, figure 2 shows this, figure 3 shows this. Your pages start to fill up. In 1 week time, you will see you already got a document which is 15 page. Now you see that you can see the end of the line. So you will think, okay, I have already finished experimental, results and discussion. What is left? Conclusion, introduction and abstract. You do this, your thesis or your paper is done. This is how you do it. You don't start to write from the title or the introduction. You do it the reverse way. Whatever is the easiest, I do first. Experimental, we do first. Just think, you may not have data, but you know how to write the preparation of MOS to quantum dots or gold nanoparticles or gold nanorods or how to do COMSOL. You can immediately write it down. So my point is, don't stop. Whatever data you have or whatever, you start writing. Start making a Word file. So don't wait for the 8th week. From the 9th week, we are going to write, right? Start writing. Open a Word file. Write the experimental. I did not teach you. Try to. So just go to any of the journals and see how they write experimental. Write it. Then I fix it. So that's how we should do it. Keep this in mind always. So this is what we need to do. Simple. This is the structure of a paper. So you need to have a title, authors, whoever has worked. I will discuss this later on. But out of these, we have learned this part and this part. Results means these are together called display items. Figures, tables, and whatever the display items. We call them display items along with caption. And then the writing. This entire thing together is result. So I have shown you a little bit about figure design, how to write captions. I will show you more about tables and other things. And you know the writing we were doing today. So these things is result. You also know the discussion part. Maybe you need to read something more, then you will be much better in that. So these 2 things we have already done. This conclusion and the abstract, they are very similar. I will show you what is the difference. So once you are done with this, and probably most of you know how to do reference, I will tell you this also. Then you will see this is very easy. This is the easiest part. This one is the easiest part. Which one is the most difficult? These 2. These 2 are most difficult. We do that at the end, once we are confident about writing. All these are easy. These 2 are very difficult to write. Because remember, abstract is a 200 word of your whole work, which is so difficult to do. Not easy. So we will do this at the end. And these 2 are the most difficult. When you start writing anything, your thesis or your paper, you have a blank Word file. That takes a challenge to start. Where to start? We start here. We start here. Experimental. That's the easiest one to do. Week 9. So we will start our project on week 9. So what you will need, all of you will need this to bring here. And this should have these 4 things. Or if you don't have Origin, okay, MATLAB, that's fine. Or Excel. Although I should tell you, Excel is not a very good quality for publication, if you are going for publication. But for thesis, it's okay. So this is not for publication. So you should need a laptop with Word, PowerPoint, Origin, and Photoshop. These are the things we need. And you should start collecting your basic data. Think of 2 or 3 figures, not much. Maybe some of you don't have much data. Just think of 2 or 3 figures, how to make those figures. Think of some schematics. If you want to explain your work, think of making some schematics. So try to collect data to make figures and try to think about the organization. How many figures? 2 or 3. How to arrange them. Think about this. I will tell you more about figure designing and schematics. So the challenge is that we need to make a 20-page document minimum with whatever data you have. So remember this whole thing, the minimum length is 20 page. So we start from here and we end up there. The total length will be 20 word pages, okay? And I have defined what is one page. One page is A4 size, 12 font, everything like that, 1-inch margin. Those kind of 20 pages. So I am looking at a document which will be 20 pages long. We need to write. So this is what we are looking at. I will show you one structure. Now I will show you what I'm trying to look at. So if you are comfortable with this structure, I show you how it looks like in a Word file. So here is one of my file, you see. So here is my title, this one. This is author. So all the authors that I have. And this is called affiliation. Biophotonics and BIRS or PET cyclotron center. So these are the affiliation. And this is the page 1. As I said, I need a 20-page document. Out of this 20-page document, the first page is only this one. That means the title, authors, affiliation, and the corresponding author's email address. You should also need keywords. So the abstract starts in a new page, always. So that's page 1, page 1. The abstract starts in a new page, so that's page 2. Out of the 20-page document that you would produce, page 1 is this and page 2 is abstract. Page 2 should contain nothing else. If you have something, you have to push it to the next page. You see? So this is my abstract, 200 or 250 words. This is only abstract. The third page is keywords probably, and you start with introduction in a new page. So now you see, this one we will do at the end. This is the most difficult part. So you go introduction, continue. So there is no page break. This is continuous. This is a schematic. So that's what I was talking about. If you don't have data, make a very good schematic. That's a schematic. Now comes experimental. So we will start from here. Experimental is sometimes called materials and methods. So in some journal, they take experimental. In some journal, they take this one. And when you go materials and methods, so you start with materials. What kind of chemicals you have used, blah, blah, blah. I will do it next week. I'm just showing you the structure. So these are materials, different materials. Now, how you do the experiment. So this is my chemistry. So I do this, I do that, a lot of things. And you will see, but I know this, I can write it. I know the chemistry, so Gordon can write it. Understand, Gordon? You need to write it, how to do these things. So this is experimental. So we will start a blank Word file, but we will start here. We will write experimental, and we will start here. So the experimental is quite long, of course. As you can see, this, I am asking you for a 20-page document, right? 20-page project. So this is a solid paper, okay? Like a lot of work. So that's a 43-page document. But I am only asking you a 20-page document. That, of course, you can make it better next time. So this is experimental. All is experimental. So like 10 or 15 page. Now you start with results and discussion. So this is what you know already. Here it is mine, but in your project it will be yours. You see? Here is the figure. This you already have in the PowerPoint. If you have the figure in the PowerPoint and with the caption, you just make it a TIFF image in Photoshop. That's why we need the Photoshop. Make the TIFF image 600 dpi. Okay? Why we need Photoshop? Because you need a particular resolution of the figure. So you need .tiff. JPG doesn't work. PNG doesn't work. It is either .eps or .tiff. These two files work. Each of them, the minimum resolution is 600 dots per inch. You can make it 1200, no problem. But the minimum is this number. For this, you will need the Photoshop. So if you have OCT image or something, make sure is this. Otherwise, they cannot reproduce. So this is what you need. If you look at this figure, how did we make it? So for example, this is my data. I put the data in PPT. Then I do these things. Then I do these things. I save it. This is another data I put in. Another data I put in. This is called composition. So now I make up my story. A, B, C, D, C, D, E, F, whatever. I make up my story. Then I group them together. I save it as image. Then I take the image, open in Photoshop. After I open it in Photoshop, I do the resolution. I do this. So in my PPT, I have 2 pages for each figure. In your PPT, you should have 2 pages for each figure. What kind? One is that you can edit. You can move like here and there. We call editable. So this is the data that you have. And the other one is after you convert them to a single TIFF, that will be your second page. So first page is your editable figure. The second page is a TIFF. TIFF you cannot change. This you can change. So later on, if you think, oh, no, maybe this figure should come here, that should go, then you do that in the editable and then save it as TIFF. So if you already have the figures with the caption, that's the caption. If you have this and this means our display items. You have 6 figures, captions, then you are good to start. Start writing this thing, okay? You get the idea? Right? It's not easy, right? But you get the idea. So you need some kind of data to put together so that I can make a figure, write the caption. And try to make it at least 2 or 3 figures that we can write. Of course, later on, when you do more experiments, you will get more data, but you will still know how to make it. So right now in this course, in the project, let's say you still make 2 or 3 figures. Later on, you can still add more, but have the same knowledge, how to make the figure, how to write the caption, how to write the result, and the discussion. Ask me questions if you have any problem about what is going to happen from 9th week. From 9th week, this is going to happen. I will sit with each one of you, and I will show you how to make this figure, how to put it over here. So start gathering your data in your computer. Start gathering your data, how to make the figures. Make something, I will correct it here. So you see, each of these things takes a lot of time. Up to 8 weeks, I will be here. Next 8 weeks, I will be with you. 10 minutes, 10 minutes, 10 minutes, like that I will go, right? Showing you what to do. So we will need that after 8 weeks. So today is 4th week, another 4 weeks we will be here. Yeah?
Should we use present or past tense in the discussion?
Oh, yeah. Okay. So that's a very good question, that when we are writing it, which tense to use? Tense, like a past tense or present tense. Future tense is out of the question. So whether we should write it in the past tense or present tense. So that's a very good question. When you are reporting about a data, you already have a data. So this is an image, SEM image, OCT image, okay? So already finished the experiment, and then you are writing it. So when you are writing about experiments or data, you write in the past tense. The phase stability of this was examined in PBS at something. Because this is the reality. I already did that 2 months back. So I write that in past tense. So the answer to the first question is we try to write in the past tense. That's easier. However, when you make a statement, I will show you what is a statement. The statement can be in the present tense. So normal writing is in the past tense. So you see, taken, past tense. Let me show you one statement, and then it will be clear. I did some kind of experiment, and that's in the past tense. Prior to the in vivo evaluation, blah, 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 was examined in vitro using something. However, look at this. Figure 4a demonstrates present tense. The photothermal temperature elevation and with increasing concentration, okay? So this is a statement. This can be in present tense. The rule is don't change tense. However, if you want to write the entire thing in present tense, sometimes it's very challenging. So what I say is, all the experiments that you have done earlier, think of that. When you are writing of the experiments, write in past tense. Statements, make it in present tense. Figure 1 shows, figure 2 shows, that's okay. You don't write figure 1 showed or figure 3 showed. So figure 1 shows, S-H-O-W-S, that's present tense. So figure 1 shows something, something. So statements in present tense, the experiments in past tense. When you write discussion is mostly in present tense. This data shows this, which matches with some et al, and the report matches with that person. It doesn't match with this person or that person. They are all in present tense. However, when you write something for the experimental, how it was done, that's in past tense. So most of the discussion will probably be in present tense, unless you want to say that similar kind of data was reported before by this person. So that's a past tense, because it has already been published, so it should be in past tense. Any statement that this work opens up the possibility of the use of point of care diagnosis, present tense. You are making a statement that my work, OCT imaging or some kind of therapy, this work opens up the possibility for point of care treatment, present tense, because you are writing a statement. So it can be a mix, yeah.
Sir, in case we were to write about this trend being observed for the first time, do we write it as it was observed for the first time or is observed for the first time?
It is a statement, is. You are making a statement, okay? There are many other rules that you will forget, so I will try to tell you. For example, when you are writing, no negative. Remember, did any of you write any negative? In this writing, the word no should not come as much as possible. I mean, don't use no. What did you ask?
I asked about the trend was observed.
Yeah, so it's present tense, always, is always present tense. There are other small nits and grits I will tell you one by one as it comes, maybe next week. So that's all for this week. Any other question?
Sir, I
Yeah.
have written a statement like this has not been reported previously.
No,
Is it okay?
you cannot, no, it's not okay. You have to change the word. Keep the meaning same, but try to replace the word not. It was not reported or something. So negative you cannot use. Sometimes it's difficult, the word doesn't come. So I say as much as possible. So in your whole manuscript, if the word no or not appears once, probably okay. But if it appears like 20 times, then it is wrong. Okay, that's it for today.